Okay, everyone. So in this lesson that you're going to watch, we are going to review because right now we're starting Unit 2. So Unit 2 is equations. So we're going to solve all kinds of equations. We're talking about good old two-step equations, combining like terms, and then solving equations, distributive property, then solve an equation, distribute, and then combine, and then solving an equation. We are going to talk about solving equations with variables on both sides. And then not only that, within each of those topics, we're going to use fractions and decimals to solve those. So it's something like what you guys did in the seventh grade, except we're diving really, really deep into it. So by the end of this unit, which is 15 school days long, so that's 3 weeks, 3 to 4. Okay, I still have to see how fast we can go. You will be able to solve any equation. All right, left and right. You will be so fluent in solving equations. Okay, you won't believe it when you look back. So, with that said, let's get started. Okay, all right. So, and here we are. So we are going into Unit 2, Day 1. The lesson specifically for today, all right, or if I change the lesson format already, as I've spoken to you in class, the lesson for tomorrow is this, okay? And then afterwards, maybe we could watch another video, all right, on equations together, and then we could get some practice, okay? It's a little more work. It's probably about 10 more minutes, 10 to 15 minutes of more work than I had planned, but I think this will keep us on track and also help everyone to really understand how to do these questions, not just today, but even 6 months down the line. So I think that's a sacrifice that we have to be willing to make. So all right, so what are we talking about here? So in this lesson, just today's lesson, we're going to review very quickly a couple of things. I want to give you some basic algebraic definitions, all right, in case you didn't get that last year, and also just kind of get you back into the groove of things where you are solving two-step equations. And then starting the next day, we can really start flying. Okay? All right. So let's take a look. So let's get some definitions down first. All right? Now, if you have to copy it, then you have to copy it. All right? These are not all the words we're going to learn at once. I want to give you some of these words that you should have learned last year, and then later on, when we are solving, we're really taking a lot of time doing polynomials, we'll get through some of these other words. Okay, so we'll come back to this. So now, right off the bat, I want you to focus on the expression in the middle. So let me use a highlighter and highlight what you should probably write down first. So this right here, right? So this is an expression. Now, what's the difference between an expression and an equation? Think about that. Yep, okay. The difference between an expression is that it has no equal sign, whereas an equation has an equal sign with a answer, right, at the end attached to it. All right, so that's the first thing, right? So an expression has so expression is a mathematical expression, is a mathematical sentence. A mathematical sentence that does not have an equal sign, right? An equation is a mathematical sentence with an equal sign to it. All right, so now let's break this down, okay? Don't get too thrown off by all these arrows and words, okay? So first things first. Let's take a look at this. Right, so first here we got 2x plus 3 equals 17. So there are a couple of things going on there. Let's look at the most obvious. This right here, the letter, we call that the variable. Now, if something is a variable, that means it can change, meaning x, if it weren't for the 17, right, x could be anything it wants to be. It could be a negative number, 0, a positive number, fraction, decimal, whatever, right? But if something can change, right, here, then we are representing a number that is a constant, which means it doesn't change. So what do they mean by that? Well, 3 is a 3, right? Like 3 cannot be a 4, and 3 cannot be a 0, and 3 cannot be negative 3. It's just 3, so that's a constant. So that's the first thing you need to know. Second, if you've noticed, there's a number in front of this variable, right? The number 2. So there's a name for that. We call that the coefficient, okay? Now, the reason why we use the word coefficient, all right, not the definition in itself, like the origin of the word, but just why do we have a, this complicated name for us? Because, imagine every time you say this. So if someone says, hey, Mr. Ng, look at the 2, and I say, which 2, right? Every time you have to explain to me, you might have to say something like, Mr. Ng, it's the 2 that's in front of the variable, right? Look how many words you just said. You just said 7 different words, right? Where you could have just said, Mr. Ng, the 2, the coefficient, right? I would have understood you perfectly. And everyone in the room would understand that too. So that's the beauty of using a word like this to represent a number in the front of the variable. Okay, now, looking further, right, you notice that this is 2x plus 3, right? The plus sign, or sometimes even the minus sign, it actually has its own function too. And that is, by using a plus sign or minus sign, it separates this expression into 2 terms. First term is the 2x, the second term is the 3. So this is a 2-termed expression. Got that? So for example, right? Let's see, what else should I tell you? Yeah, so for example, a term can only be separated by a plus minus sign. Plus or minus sign. It's never multiplication or division. No. Okay, here's why. Look at this, right? 2x, what's the operation between the 2 and the x? That's right, it's multiply, but yet this is one term, right? So that means multiplication cannot be made as a separator of a term, because multiplication puts them together, right? Whereas a plus minus sign separates this expression into one term and then 2 terms. Okay, so that's a lot of information if this is your first time seeing it. All right, so if you want, you can rewind and rewatch this. I think I've covered everything here. Now, having said that, let's look at these 5 examples. Looking at the first one here, how many terms are there? Right, 1, 2, 3, 4, 5, right? So there are 5 terms here. Looking at the second one, right? How many terms are there? Yep, 4. 5. 1, 2, 3, 4, 5, right? Now, let me pause for a second. Let me see if you guys remember what I've said so far. Let me use a different color pen. What is the coefficient for this term right here? What's the coefficient of this term? Yep, it's 5, right? What's the variable for this term right here? Notice how I include the negative sign, right? Okay. What's the variable of this term here? That's right, x, right? What do you call the plus 1 here? What's the name for it? Right, it's a constant, right? Okay, here's another trick question. Looking at this term here, what's the coefficient? What's the number in front of the variable? Now, please don't say 0, right? You don't see a number here, right? Don't say 0, it's not 0, what is it? Yeah, it's 1. The coefficient here is 1, 1x to the 5th power, right? Okay, all right, just checking. Now, how are we doing on time already? Yeah, all right, so next, looking at this one, all right, how many terms are there? Right, just 1 term, right? What's the coefficient? 56. What's the variable? Yep, x, right? All right, looking at this one, how many terms are there? Right, 2 terms, right? And then what's the constant? Right, -7, right? Okay, looking at this last one, how many terms are there? Right, one term, right? And it's only a constant, right? What's the coefficient of this term right here? What's the coefficient? None, right? There are no coefficients, right? Because there's no variable. So how can you have a coefficient, right? So that was a trick question, okay? All right, now, we got names for these sort of numbers of terms things, okay? Now let me see if I wrote this down somewhere. No, I did not. Okay, so I'm gonna have to write this down. Yep, okay, all right, so let me write this down then, down here. So, a one-term expression, we have a name for that. We call that a monomial. A two-term expression, we have a name for that. What do you think it's called? What word, what prefix tells you that there's something called two? All right, now in my old classes, someone might say two-nomial, okay? It's not, it's binomial. What about three terms? What does that call? What's the prefix for three? All right, again, not a three-nomial. Someone said something really funny, like when I taught this a couple of years ago, all right? But this is called a trinomial. Now, after three terms, we don't really say like, quadnomial and none, any of that. Anything more than one, meaning many terms, we have a name for that, all right? What's the prefix for many? Yeah, poly. All right, someone said many-nomial before. So that was kind of funny. All right, polynomial. Okay, so let me see. Let's check off these words here: expression, equation, variable, constant, coefficient. We'll talk about leading coefficient later on. Degrees, not yet. Term, monomial, binomial, trinomial, polynomial. Okay, perfect. All right, let me stop the lesson here. All right, and I gotta figure out what we're gonna do to review two-step equations. And I don't want to spend any time in class on this. So you know what? Let's use class time to practice two-step equations and then moving on from there. Okay? All right. So, all right. Thanks for watching. Have a good one, and I will talk to you later. Bye-bye.
OMG, that was so good.